Okay, this is the absolute value, part 4. You should have been given a handout to take notes with. I'm going to go pretty quickly, but remember, it's a video. You can pause it, rewind it, and watch it again if you miss something. Make sure you stop it and do the problems that say now it's your turn on your own, and then check your work afterward. So here we go. The absolute value we've looked at several times, but the definition of the absolute value is simply the distance a number is away from zero. So you can either go to the right in the positive direction or to the left in the negative direction, and both answers answer the question of what is the absolute value. For example, if I give you the absolute value of x equals 5, you can imagine, not have to draw, but imagine a number line. How far away from 0 is 5? Well, 5 is 5 in the positive direction away from 0, and 5 in the negative direction from 0. So the answer to the absolute value of x equals 5 would have to be that x could either be positive 5 or x could be negative 5, because both answers answer the question, how far away from 0 is 5? Another way to think of it is that if I put positive 5 in place of x, the absolute value of positive 5 equals 5. If I put negative 5 in place of x, the absolute value of negative 5 also equals 5. So you can see that when I have a variable inside the absolute value, there are two possible answers that I could get that would make this equation true. And what you're going to do today is solve equations that have absolute values. So again, you're just copying notes down for now. The first step in solving an absolute value equation is that you isolate the absolute value part. You get the part that has the absolute value symbols all by itself. And then the second step is set up two different equations, which I'll show you in just a second. So take a second to make sure you have everything that you see on the screen copied into your notes, and then we'll move on. Okay, so here's an example of how you solve an absolute value equation. This first problem says the absolute value of x plus 1 minus 2 equals 0. The first step, as you wrote above, is to isolate the absolute value part. I want to get this part all by itself first. So to get that part all by itself, I add 2 to both sides of the equation. Adding 2 gets rid of this minus 2. And now I have absolute value of x plus 1 equals 2. The second step is to set up two different equations with this absolute value. What that means is that the absolute value of x plus 1 could be equal to 2. X plus 1 could be equal to 2. Or the absolute value of x plus 1 could also be equal to negative 2, because what's inside the absolute value, if I take the absolute value of it, will always end up being positive. So I solve each of these two equations. X plus 1 equals 2. I solve this by subtracting 1. I get x equals 1. Then I solve the second part. X plus 1 equals negative 2. I subtract 1. And there are my two solutions. So, just to make sure you understand how this works and that it does work, if I check my answers by putting 1 in place of x in this equation, 1 plus 1 minus 2. 1 plus 1 is 2. The absolute value of 2 is 2. 2 minus 2 equals 0. That checks out. Then I can put negative 3 in place of x back in the original equation. Negative 3 plus 1 minus 2 equals 0. Negative 3 plus 1 is negative 2. The absolute value of negative 2 is 2. 2 minus 2 equals 0. That one checks out. So by solving this absolute value equation, I come up with two answers, x equals 1 and x equals negative 3. Okay, let's take a look at the second equation. The first step in solving an absolute value equation is to isolate the absolute value part. Get this part all by itself first. So to do that, just like if I had an equation, the first step would be to get rid of the minus 4 by adding 4 to both sides. If I do that, I get 2 times the absolute value of x minus 3 equals positive 4. The next step to get the absolute value part all by itself is to get rid of this 2 on the outside. The 2 on the outside is being multiplied. So to undo or get rid of multiplication, I do the reciprocal or opposite, which is divide. Divide by 2, divide by 2. I'm left with x minus 3 in absolute values equals 4 divided by 2 is 2. That's the end of step 1. I have the absolute value part all by itself. I've isolated it. Now I'm going to set up two equations. The two equations will always be whatever's inside x minus 3 equal to the positive answer, which is positive 2, and whatever's inside equal to the negative answer, which is negative 2. I set up the two equations, and then I solve. Plus 3, plus 3. One answer is x equals 5, plus 3, plus 3. The other answer is x equals positive 1. Those are my two answers. Now, you give it a shot. At the bottom of your worksheet, there are two examples that say, now it's your turn. Try those two. Pause the video, and then when you're finished, check your own answers. So here we go. First step, isolate the absolute value part. Add 5 to both sides. You get absolute value of x minus 2 equals positive 5. You have the absolute value part all by itself. Now you create two different equations. One that says x minus 2 equals positive 5, and one that says x minus 2 equals negative 5. Solve each equation by adding 2 to both sides. You get x equals 7, and you get x equals negative 3. The second part, part B, same set of steps. Isolate the absolute value part by first adding 21 to both sides. You get 3 times the absolute value of x plus 8 equals 21. Next, divide both sides by 3. You get the absolute value of x plus 8 equals 7. You have the absolute value part isolated. Now you can set up two different equations. X plus 8 equals positive 7, and x plus 8 equals negative 7. Solve each equation by subtracting 8. You get x equals negative 1, and x equals negative 15. Okay, turn your worksheet over. On the back side is a couple of problems that show the same problems that we just completed, only now I'm asking you to graph them. And this is what we did yesterday. So if you graph the first equation, y equals the absolute value of x plus 1 minus 2, recall from yesterday that you can find the vertex and find the solutions by looking at the graph. So in this problem, you can find the vertex just by noticing the h and the k. So the vertex for this graph is negative 1, negative 2. So if I graph it, the vertex is -1, -2. The slope of this graph, since there's no number in front of the absolute value, is just 1. So I go up 1, over 1, up 1, over 1, up 1, over 1. And then do the same thing on the other side. And just like yesterday's assignment, you can tell where the solutions are just by looking at where they cross the x-axis. This graph crosses the x-axis at 1, 0 and -3, 0. Same is true for the second equation. I can find the vertex. It's 3, -4. That's at 1, 2, 3, 1, 2, 3, 4. I can graph this by using the slope, kind of. That means I go up 2, over 1, up 2, over 1, and then the same thing in reverse. There's my graph. And I can tell that this graph crosses the x-axis at 1, 0 and 2, 3, 4, 5, 0. Now, looking at the graphs, looking at where they cross the x-axis, what do you notice about the solutions of the graphs and the solutions that we looked at in example number 1? Well, if you go back to number 1, the answers were 1 and 5, and the answers here were 1 and 5. So if you graph the absolute value functions, you get the same thing as if you graph or if you solve the equations by letting the y equal 0. Okay, the last example has 3 graphs and 3 solutions. The graph of the absolute value equation y equals -2 times the absolute value of x plus 1, this one, and the graph of this one and the graph of this one will give you the same solution as if you solve this equation and this equation and this equation using the method that I just taught you, using the 2 steps. Isolate and then set up 2 different equations. So take a second to graph each of these and then solve each of these, and then pause the video and then check your answers when you're finished. All right, by graphing these 3 equations, what you should notice is the first equation gives you 2 solutions. This solution here is at 1, 0, then the solution here is at -3, 0. It crosses the x-axis twice, it's 2 solutions. The second graph comes down and touches the x-axis just once at 3, 0. It has 1 solution. And the last graph never crosses the x-axis. It has no solution. By solving the equations the new way, you're going to isolate the absolute value part by subtracting 4 from both sides. Divide both sides by -2. You get x plus 1 equals 2. And then you set up 2 equations. X plus 1 equals 2. and x plus 1 equals negative 2. And then by solving each, you get x equals 1 and x equals negative 3, and that matches what you did on the graph. The second one, it's already isolated. The absolute value part is already isolated, so you set up two different equations. X minus 3 equals 0, and, oh wait, x minus 3 equals 0. 0 doesn't have a positive or a negative, so there's just one answer. You add 3 to both sides, you get x equals 3. Just one solution, just like the graph says. The last equation, follow the steps, subtract 1 from both sides to isolate the absolute value part. Multiply both sides by 2. You get the absolute value of x minus 2 equals negative 2. Now here's the tricky part. When you take the absolute value of anything, you'll always get a positive answer. And because this equation says the absolute value of x minus 2 equals negative 2, that's not possible. That's no solution. So when you're graphing and trying to find the solutions, you're just looking where it crosses the x-axis. When you're solving an equation using absolute values, you'll either have two solutions, one solution, or no solution when you end up with a negative number. All right, your job now is to look in your OneNote notebook, and you'll find the absolute value part 4 assignment. Complete the equations by solving each, and that's it.